Cool. Okay. So straight line, parabola, hyperbola, exponential. We're going to start with the parabola function because out of the three or out of the four, I think it's the most complicated one because we go in depth like a whole chunk in grade 12. So let's explore that. The parabola function. Okay, so a parabola function is usually when we have an x squared. So when something is squared, when you have x squared. Okay, I'm just going to add an extra few bit here, and I'm going to title this as the standard form for the equation of a parabola. So this is the standard form. Normally, when they give you the equation of a parabola, they normally give it to you in the standard form. They can give it to you in other forms as well, but usually it's in the standard form. Okay, this is when you have ax squared plus bx plus c. It's like a trinomial. Well, it is a trinomial. Okay. And we actually use a and b's value to work out the x coordinate for the turning point. So we use a and b's value to work out the x coordinate at the turning point. Use a and b's values to find x coordinate at turning point. Okay. I hope you guys can see what I wrote here. We use a and b's value to find the x coordinate at the turning point. Does anyone know the formula to work out the x coordinate of the turning point? Sumila, do you know this formula?
Sir, could you please repeat?
Okay, so I'm just going to read the sentence out. It says, we use a and b's values to find the x coordinate at the turning point. What formula are we talking about here? What formula is that we can use a and b to find the x coordinate at the turning point?
I'm not really sure, sir.
Okay, let me see. Does anyone else know perhaps or remember what this formula is for the turning point? It only works on parabolas, but it's a very neat small formula. Okay, I'll write it down. The formula is x is equal to negative b over 2a. Have you seen this formula before? Negative b over 2a. Okay, so we start here. We use a and b's value to find the x coordinate at the turning point. And then once we have the x coordinate, we can substitute our x value back into the equation to find the y value. Okay, so this is like when you have the x value, you can just sub it back there to find the y value. Okay, so pretty simple, and straightforward, but I will do an example where we go through this. Something I didn't mention, let me just put it in there. C's value over here, C's value is the Y-intercept. That's always an indication of the Y-intercept. So I'm going to say indicates the Y-intercept. Okay. I think I'm just going to stop here for a moment, and I'm going to do an example of where the parabola is given in the standard form before we go further with parabolas. Okay. So now that you got this, I'm just going to erase it, then we continue. Okay. Okay. First example. And this example is about drawing a graph. We are going to draw the graph negative x squared minus 2x plus 3. Negative x squared minus 2x plus 3. Okay. Now, whenever we are drawing functions, there's like important things that we need to find first. And those two important things are the intercepts. That's your x-intercept and your y-intercept. Humelo, how do we calculate the x-intercept? How can I work out an x-intercept?
Sir, don't you wait? Do we use the formula or do we make y 0? I think don't we use the negative b over 2a?
Negative. The
But
negative b over 2a.
Turning point.
Yes, that's for the turning point. So you were right the first time when you said make y 0.
Yes, sir.
Okay. So to calculate an x-intercept, you need to use this equation and make the y value 0. So fx in this case is our y. We are going to make y 0. And then to work out the y-intercept, remember we can just read off this value as a y-intercept. So 3 is an indication of where the y-intercept is going to be. It's going to be 3 on the y-axis. The turning point, we can use that formula, negative b over 2a. And in the shape of this graph, because it's negative x squared, the shape of the graph will look something like this. Okay. So write down these 4 bullet points, and then we're going to draw a nice curve. We're first going to calculate what the x-intercept is. We know what the y-intercept is. We'll work out the turning point. Then we'll draw the shape. Okay. So to start with the x-intercept, we said we're going to make y 0, and we're going to solve x. Okay. So I'll do that by first dividing this entire equation by a negative. So 0 will stay 0, but this becomes positive. That also becomes positive, and the 3 becomes negative. I'm dividing the entire equation by negative. Next, I will factorize. So the factors of x squared is just the x and the x. The factors of 3 is only 3 and 1. 3 gets a positive, 1 gets a negative. 3 minus 1 gives us 2, right? And so the answers therefore is negative 3 or positive 1. Okay, so the coordinates for our x-intercepts is negative 3 and 0 and 1 and 0. Now a parabola will mostly have 2 x-intercepts. Sometimes it can only just have 1 intercept. That's when the turning point is on the x-axis. But other times it can also have no x-intercepts. That's when the parabola is above the x-axis or below the x-axis, and it doesn't ever cross the x-axis. Okay, so those are the three kinds of I guess scenarios you can get. But in this case, we have 2 x-intercepts. I think in most parabolas that you guys will be doing, there'll be 2 x-intercepts. But I just made you aware of the other cases as well. Okay, so we said the y-intercept is just going to be that 3 over there. I guess the next thing for me to do is work out the turning point. Okay. Right. So we'll start with this formula, negative b over 2a. Right. A's value is the -1 that's in front of the x squared. And then -2 is the b value in front of x. Okay, so we substitute that. -2 divided by 2 multiplied by -1. Can you guys punch this in your calculator, or maybe just simplify in your minds and then let me know what the answer is? See, sorry about that. Okay, I see Tando's also here. -1, thank you. -1. So this is telling us what the x value at the turning point is. Okay, I'm only working out the x value. I still now need to work out the y value. Sumila, how do I do this now again? How do I work out the y value once I already have the x value?
So once you plug it into the original formula?
That's correct. So you plug it back into this equation because remember, fx is y. So to calculate y, we can just use this formula. So I'm going to say, therefore, y is equal to, and now I substitute this -1 with that x. So it's -1 squared minus 2 times -1 plus 3. Let's do the calculation here. That's equal to 4. Yeah, so the y value is 4. Any questions, guys? Okay, so whenever you work at a turning point, make use of this formula, especially if you are given the standard form. Okay, if you're not given the standard form, you can turn it into the standard form if you want to by just multiplying the brackets out. Like if it's given in the turning point form or the X-Intercept form, just multiply those brackets out and you can end up with this standard form. Otherwise, there's actually much easier ways of finding the turning point, especially if it's given in the turning point form, because then you can just use that. But otherwise, let's get to drawing this graph. So we said the shape of this graph is going to be a sad-faced parabola. That's because this x squared is negative. So let's start out by doing a Cartesian plane. Let's indicate points on here up until 4. So 1, 2, 3, 4. -1, -2, -3, -4. Then we go up by 4 as well. 1, 2, 3, 4. -1, -2, -3, -4. Okay, my spacing isn't exactly accurate, but I'm trying my best. Okay, so let's start plotting. Our x-intercepts was it +1 and -3. Okay, so I'll put a point here by +1 and another point here by And then I'm also going to put a point by +3 on the y-axis, because that's the y-intercept. And then we calculated the turning point at -1 and 4. -1 and 4. So that's to the left, but upwards. So it's in the second quadrant. And now we draw a parabola. Make sure to turn the parabola at the turning point. Don't turn it at the y-intercept. It must turn at the turning point, the highest point on the graph. Okay. So if you guys are happy with this, we can now move on to the other forms of a parabola, such as the turning point forms and the X-Intercept forms. Or maybe what I'm going to do with those forms is I'll show you how to work out the equation of a parabola using those forms. Okay, so let me first introduce the forms, and then we'll have a look at some examples. So we're going to start writing this here. Yeah. This is the turning point form. The turning point form of a parabola. Okay. A very notable and famous one that we need to know for when dealing with the parabola function or any quadratic expression or something that you're dealing with. This is always important. Even when we deal with quadratic patterns, you know, the quadratic pattern in sequence and series, then it's also useful to know things like this. Now, the turning point form does exactly what it says. It gives you an indication of where the turning point of this parabola will be. And in fact, P and Q are the X and Y values at the turning point. So let me write it down. P and Q are the X and Y values. X and Y values at the turning point. For example, if there's a turning point, then the X coordinate will be P and the Y coordinate will be Q, for whichever value P and Q is. Let's say in this equation, if I have X minus 1 squared plus 4, then my turning point will be 1 and 4. Make sense? If I add X minus 1 squared plus 4, my X coordinate will be 1, my Y coordinate will be 4. So let me ask, not so much as a trick question, but just to see if you're following along. If this bracket, if inside this bracket I had X plus 2 squared and then plus 3, what would the coordinates for my turning point be? Let me repeat. If I had X plus 2 squared plus 3, what will the coordinates for this turning point be? You guys can feel free to write it in the chat or even turn your mic to answer. -2 and 3, that is correct. -2 and 3. So you see this negative in the bracket? It means that there's always going to be a trick with P. So if I say x plus 2, then the x coordinate is -2. If I say x minus 2, then the x coordinate is +2. So it's always opposite as to what P's value is going to be. Or not P's value, but it's opposite as to what this bracket will look like. If that bracket is positive, P's value is going to be negative. Okay, because of that negative inside the bracket. Q's value will stay exactly the same. If Q is positive, the Y value here is also positive. If Q is negative, the Y value here is also negative. Okay. Then A again just tells us it's an indication of the shape of the graph, but to work out A, we would substitute a point. So let me just write it down. To calculate A, you will substitute a point. Any point that is on the graph. If there's any other point that is on the graph, maybe like a Y-intercept or X-intercept or any random point, you can use that point, sub it in the X and Y, and you can work out A. Okay. So before I do an example, let me just do the X-Intercept form. That's the last form of the parabola. I call it the X-Intercept form, but there's many other names for it. People call it the root form or whatever. I'm just going to refer to it as the X-Intercept form because it basically tells you what the X-intercepts of the graph will be. Okay, so I'm going to erase this off. You just need to keep in mind that all of these are parabola functions. All of this is parabola graphs. Should I put an R or let me just put an X there. Okay. Okay, so it says A bracket x minus x1 bracket x minus x2. This is the X-Intercept form. And we can use this form if we are given the X-intercepts, or if you want to find the X-intercepts. Yeah. You can see this is like a factorized version of a trinomial. Remember we said the parabola is basically a trinomial. And so when we factorize trinomials, this is how it looks. This is the coefficient of x squared, and these are the factors. Okay. Yeah. By the way, the turning point form, if that didn't look familiar, that we actually get by completing of the square. Yeah, so that's completing of the square again. Let's have a look at this. Okay, so this is pretty simple. These x1 and x2s are the x-intercepts of the parabola. So x1 and x2 are the x-intercepts of the parabola. So again, let me just pose a question while you guys are copying this down. If this was x minus 1 and x plus 2, if this was x minus 1 and x plus 2, what will the two x-intercepts be for this parabola? If I had a function x minus 1 and x plus 2. What would the x-intercepts be for this function? Again, just switch on your mic or use the chat. 1 and -2. Thanks, Tando, that is correct. 1 and -2. For this bracket, it's 1. That bracket is -2. Again, watch the fact that there's a negative inside this brackets means that the values that is inside the brackets will change. Okay. Once you translate it to the x-intercepts, this is a positive 1. That is a -2. Okay. Perfect. And then to work out a's value is all the same. We are just going to substitute a point. Sub a point. Any point that is on the graph. What's happening? Sub a point. You just substitute any point on the graph to work out a. So I'm going to do 2 more examples. This is the oh, I should say example 2 now because we already did the first one. Find the equation for the parabola. Okay, copy this down and then we're going to work out the equation for this parabola. X-intercept, sorry, x-axis, y-axis, and then this curve over here, that is the parabola. So I showed you guys 2 forms now. The form of an x-intercept and the form of the turning point. Which of those 2 forms will we use to find the equation of this parabola? Which do you think will be more convenient given what we know about this parabola? The turning point form, that is correct. Thanks, Sumina. So we'll start off with this turning point form. A bracket x minus p squared plus q. Okay. So now I'm just going to go through this together just to save time. We're going to substitute p with this x value at the turning point. We substitute q with the y value at the turning point. And then we're going to substitute this other point on the graph, which is the coordinates of this will be 0 and -6. Because -6 is the y-intercept. So it means that the x value here is 0. Okay, so we're going to substitute those 2 coordinates with x and y so that we can work out p. So that we can work out a, sorry. But let me first substitute this. Okay. So I'm going to substitute p as 1. So that becomes x minus 1. And then I substitute q with -8. So then this becomes -8. All right. Now, like I said, I'm going to substitute the point here. Sub point 0 and -6. So -6 is our y value. and 0 is the x value. And why are we doing this? To work out a. So let's just continue. -1 squared is 1. I can take that 8 across. So then -6 plus 8, what's that? 2. So a is equal to 2. Perfect. Now you actually know what the equation of your parabola is. It's going to be fx is equal to 2x minus 1 squared minus 8. That's the equation to the parabola. Let me just write it out in full. Two x minus 1 squared minus 8. There you go. Okay, so if you do want to find this in the standard form, you can just multiply the entire thing out. Like I would start out by multiplying these brackets. Let me just move the camera over. So I'd start by multiplying out these brackets. That gives me x squared minus 2x plus 1. Then I multiply the 2 inside the bracket. 2x squared minus 4x. Now, if I multiply 2 with 1, I get 2. But since I'm minusing 8 from that, it becomes minus 6, which is the y-intercept of this parabola. Okay. So this is now the equation in the standard form. Let's say you wanted to find it in the x-intercept form, because you maybe want to know what the x-intercepts were. So we can factor out the 2, take out 2 as a common factor, and then we can factorize x minus 3 and x plus 1. And here you can now see what the x-intercepts is. It's positive 3 and negative 1. Okay, so here we have the parabola in 3 different forms. The one on top was how we worked it out. That was the turning point form. Then we multiplied that out to get it in the standard form. And then we factorized it as a trinomial to get it in the x-intercept form. Okay. By the way, I mentioned this before in this lesson, so I just want to see if you guys were listening. How would we go from the standard form back to the turning point form? How could we go from the standard form to the turning point form? What method of factorizing can we use to go from this to that?
So so wouldn't you use the when you have to when you have to wait a minute, I need to find the
Yes.
right term now. I need to find the right term. When you need to like take the b value and then half it and then add it to the other side and stuff like that. But I forgot the word for it.
Completing of the square.
Completing the square, yes.
So you half the coefficient of x, so that's the b value you're talking about. Half the whatever. So half the coefficient of x, and then and squared. But in this case, we don't have two sides. Like you mentioned, added to both sides. We don't have two sides in this case. We only have the one side. So when we add it, we're gonna have to subtract it as well, because we don't want to make it change the value of the function or change the shape of the function. It needs to be the same. So let me just show you how we would do that. Let's just title this completing of the square. Okay, So if we have fx equal to 2x squared minus 4x minus 6, let's first break it up. No. Let's first factorize by taking out a 2. Okay, this x squared has to be, there needs to be a 1 in front of it. Okay, so we need to factor out the 2 so that it can be 1x squared minus 2x, and I'm going to leave a space here, minus 3. I leave a space here as well, close the bracket. Okay, now inside this space is the thing that I'm going to add and then subtract again. Okay, so the same thing that I'm adding, I have to subtract it again afterwards. That's half the coefficient of x. So the coefficient is -2. I'm going to half that to give me -1. Then I square it, and I do the same here. So first I'm adding it, then I'm taking it away. Okay, so it cancels each other out. Now, these 3 terms I'm going to factorize, and then these terms over here I'm going to add. Just add them up. So when I factorize the 3 terms over here, I get x minus 1 squared. Simply this x and that minus 1. So it's like when you're finding the equation of a circle by completing the square. Again, I'm just going to add these up. This is -3 minus 1. So that's -4. And then I multiply with 2 inside the bracket. So 2 is being multiplied with this first bracket, and it's being multiplied with the 4. So therefore we have 2x minus 1 squared minus 8. Okay, and this is the equation of the parabola in the turning point form. Obviously, we already knew this because we got to it first, but I just wanted to show you that if it wasn't given to you in this form, you can still work it out like this, doing completing of the square. Okay. Let me just check the time. There's not a lot of time left, just about 10 minutes, but I really just want to do, or at least introduce the hyperbola function. And then when we have time, we can go through, oh no, we're going to still spend a lot of time on the exponential graph because I will still do logs with you guys. Or maybe I have done it, but just to expand more upon that, we're going to do exponentials and logs together. Yeah. Also, I'm going to give you guys homework on this functions, the parabola and the hyperbola. So yeah, let me just do the last function with you, and then we can end our lesson. Okay. Hyperbola function. Now, maybe you've gotten a little rusty with this function, but let me just show you the shape of it. The hyperbola function usually looks like this, and like this. So you have 2 symmetrical graphs. Pardon me, sorry. You have the 2 symmetrical graphs drawn in the first and third quadrant, but it can also be drawn in the second and fourth quadrant. That's if it was negative. And then these graphs have asymptote lines. So the first asymptote will be on the y-axis, that's a vertical asymptote. And then it has another asymptote on the x-axis, that's the horizontal asymptote. The horizontal asymptote will always have an equation y is equal to. Okay, if it's on the x-axis, then y will be equal to 0. If it moves up or down, then this y value will change according to how far it moved up or down. This vertical asymptote is on the y-axis, and it has the equation x equal to 0. again, if the graph moves either left or right, then the value of this asymptote will also change to either positive or negative. Okay. So if it moves to the right, then this asymptote will be positive. If it moves to the left, then the asymptote will be negative. Okay, but we're going to see what this x value's effect is on the graph. Okay, so let me give you the equation or the standard equation for this graph. Standard equation for a hyperbola. Y is equal to x over x minus p plus q. Notice we again have this negative here with the x, with the p. So p's value is always going to be a tricky one to find. Q will just be exactly what it is here, but p will change. Okay, so you just need to keep that in mind. If this is x plus 1, then it means that p's value is negative 1. And if it's x minus 1, then p's value will be positive 1. Okay, because of that negative. So let me just write down what p is. P is the x asymptote, or it's an indication of where the x asymptote will be. So what should I say? P indicates the value of the x asymptote. Okay, but you understand what I mean. And then Q's value indicates the value of the y asymptote. The value at the y asymptote. Okay. Important parts here is x asymptote, y asymptote. So P is related to the x asymptote, Q is related to the y asymptote. And then A's value, in the same way we did with the parabola, to work out A, just A determines the shape, whether it's going to be in the first or third or the second or fourth. But we can work out A by just substituting a point. So it's the same what we did with the parabola function. We just subbed a point. Sub a point. And that's how we work out A. So this is the last example that I'm going to do today. I think this is example 3 now. Okay. In fact, we are going to draw fx. Draw f. Okay. Now, when we had to draw the parabola, we had to find the x-intercept, the y-intercept, the turning point, and we had to know the shape of the graph. For this one, we're also going to find the x-intercept and the y-intercept, but we're not going to find a turning point because this graph doesn't have turning points. This graph has asymptotes. So we need to find the asymptotes to this graph, and then we're going to draw the shape. Okay. And this graph will again be drawn in the first quadrant and the third quadrant. So it will look something like this, with the asymptotes being here and there. Okay. So let's first work out the x-intercept. And we do that by making y 0. Okay, now we can just solve x by taking the 2 across and then cross multiply. My method of solving this is always not the best method, but it's an effective one. It's one that I use very often. So I take the 2 across and then I cross multiply. So this becomes negative 2x plus 2 equal to 4. If I take that 2 across, the 4 minus the 2 is just 2. And then I divide by the negative 2 to get x equal to negative 1. This is my x-intercept at negative 1. Okay, now I need to find the y-intercept. Okay, to do that, I'm going to make x 0. So 4 over 0 minus 1 plus 2. That's 4 over negative 1, which is negative 4. If you add 2 to negative 4, you get positive 2. No, you get negative 2. You get negative 2, sorry. Yeah. So the y-intercept is at negative 2 and the x-intercept is at negative 1. We're going to draw a Cartesian plane so that we can plot these 2 points. Then we are also going to identify what the x-asymptote is and what the y-asymptote is. And then we draw a nice curve. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5, 6. Okay. The x-asymptotes was at negative, sorry, the x-intercepts was at negative 1. And the y-intercept was at negative 2. Am I right? Yes, negative 2. Then we had asymptotes to this graph. The first asymptote, the vertical one, is going to be at positive 1. At positive 1. Remember, p's value is 1. So the vertical asymptote will be at positive 1. Going through the point where x is equal to 1. Okay, then we also draw a dotted line for the y-asymptote, which is at 2, at positive 2. Y is equal to 2. Okay. So let's draw a nice curve in the first quadrant between the asymptotes, and then a second curve in the third quadrant between the asymptotes. Okay, make sure that it passes through these 2 points that we calculated, the x-intercept at negative 1 and the y-intercept at negative 2. Okay.
So
Yes.
So did I hear you correctly? So in the beginning when you said this graph doesn't have intercepts, but it has asymptotes.
It doesn't have turning points.
It doesn't have turning points. Okay, thank you, sir.
Okay, it doesn't have turning points, but it does have asymptotes. And it will have intercepts. There are some cases where it doesn't have x and y intercepts. That is when the asymptotes are on the x-axis or on the y-axis. If this y-asymptote is on the x-axis, then we won't have any x-intercepts. And if this if this x-asymptote is on the y-axis, then we won't have any y-intercepts.
All right,
Okay.
thank you, sir.
Okay. But it can have intercepts, like in this case, we do have intercepts here. Okay. There are there's one more question about this graph, which is a very famous question. It's about the line of symmetry. Now, symmetry is a line like this. As you can see, this line is a mirror to the two graphs. Okay, that's a line of symmetry. And there's, in fact, another one that goes like this. It always goes through this point where the two asymptotes meet. And the equation for this one is y equal to x plus c. This one is y equal to negative x plus c. To work out c, you can just substitute this point where they meet. That's the point at 1 and 2. Okay, thanks guys. We're gonna end our lesson here. Oops, I see the camera fell. But yeah, let me just cancel that.